Morning, everybody. David Shapiro here with another video. Sorry I missed yesterday. I was feeling rather tired. Woke up after only 4 hours of sleep, and yeah, I've been really focused on some of my projects. Make sure am I still centered? Okay, yes, centered. All right, so we've got a busy day today since I missed yesterday, so this will probably be my only video of the day. First up, we've got NVIDIA Jetson Orin. So for those who are not familiar, their Jetson series is small mobile edge AI. So I have a Jetson Nano, which is like 10 times less powerful than this guy. So let's go ahead and just dive in. I'll show you on the Learn More tab. So they've got the board level, a little bit of a diagram of what all is included on the board. But like taking a step back, like what do you use this thing for? This is a developer board for prototyping mobile applications or portable applications. And so you see here, you got some or I guess like another example, like what can it do? You can do video inference, you can control robots, that sort of stuff. But yeah, okay, so you've got 512 core NVIDIA Ampere or 1024 core. Okay, sure, but how does that compare to previous generations? So here you go. I have a Jetson Nano, which, okay, sure. I think I spent like $400 on it. But look at this guy. You go from a performance factor of 7 to 134. So that is more than an order of magnitude. That's 2 orders of magnitude, or almost 2 orders of magnitude, better performance. Yeah, so that's 20 times the performance, almost. Yeah, and you see that kind of increase across the board pretty much. So you go from, for LPR, which my brain is not supplying what that means right off the moment, from 47 to 534, for dash cam, 11 to 198, for body pose, from 3 to 68. So yeah, you get these, and this is just the introductory version. Yeah, and obviously you get twice the performance if you have a core that's twice as dense. Yeah, so these are next level. They are more expensive. So for instance, the full developer kit. Let's see, where was it? I think they're like $2,000. Here, let's go to Jetson Orin. Learn more, autonomous machines. It's pretty though. Look at that. Small form factor. Getting started guide. That's the comparison. Where is the pricing? I know I looked at it. Huh. Okay. Well, I'll post it in the links if I can find it. Anyways, just the raw. Oh, here's some prices. Yeah. So Jetson AGX Xavier. Yep. So all the different prices are here. Yeah. So this is interesting. If someone wants to send me one, I'd love to play with it. But usually I'm more on the high end stuff. Portable, mobile, and edge AI is a whole different domain. Okay. So next up from NVIDIA, we've got NeMo, their LLM service. So what is NeMo? The NeMo homepage. Sorry, let me go back up to the top. NVIDIA NeMo is an open source framework for developers to build and train state-of-the-art conversational models. So this is end to end. This has voice and language models. This is kind of their flagship. It's based on Megatron, the 530 billion parameter language model. So this is 4-ish times bigger than GPT-3 and Bloom. I have no idea how well it's going to perform. But there you have it. And so they've actually opened up, you can apply for early access, which of course I have as a researcher who studies alignment, cognitive architecture, and now I'm focusing also on generating long form fiction. I obviously want access to this. They require an NDA for granting access, so even if I do get access, I probably won't be able to talk about it. We'll see what the NDA says. And that's, of course, if I get access. But it's very exciting because this is a huge model and it's going to be powered by NVIDIA, which is, other than Cerebrus wafer scale engine, the best on the market for running AI. Yeah, so that's also very exciting. We'll move on from there. Another thing, speaking of large language models, is Petals. So someone on my Discord helpfully shared this. So what is Petals? It is exactly what it says right here. It's a decentralized platform for running 100 billion parameter language models. So if you remember SETI at home or folding at home, this was a case where you'd have an agent running on your machine and you would receive workloads from the cloud or from a distributed peer-to-peer network. Your machine would work on part of the workload and then send the results back. This is similar, but instead of running like a little folding experiment or processing some radio data, what you're going to be doing is actually processing one or two layers of a large language model, and you will be a node in a network. So you'll basically break apart a large language model into many, many nodes to run across many machines. And then you'll receive just a part of that layer, and then you'll pass those results back. So they say that it's still pretty fast and so on. I've got the paper pulled up. So let's see. There was a good graphic that kind of shows it. Well, so first here you see like they've got a little distributed network. But yeah, so here's a very simple example. I love how all the GPUs have little googly eyes. So basically you have multiple clients all contributing workload demand. And so then there's different people with GPUs hosted all over. And so then they get, you contribute your GPU. So you're running workloads for other people and other people are running workloads for you. And so it's a peer-to-peer network of GPUs basically. So structurally, I don't know if it's actually similar to the way that folding at home or SETI at home was done. I'm just pointing out that this has been done before. It's been done for decades. Literally, I had a folding at home set up on my laptop when I worked at more than 10 years ago. And of course, distributed computing has been around for a long time. But so this is just the next logical development of that. So good little graphic there. I like pictures. Let's see. And they talk about the performance and all the methods. So what I think is most interesting is they talk about like what are the incentives, right? So if you contribute, so when there was folding at home and SETI at home, really the only incentive was you got to be on the leaderboard, right? It was publicly stated how many packets you had processed or whatever. But in the era of cryptocurrency, you could actually earn provable work, right? Like the proof of work is work that you're actually doing for the world. And so you get points or tokens or something, and we'll get to this in a minute. And so then you can spend those tokens for whatever. They're just speculating that this is something that you could do. But say, for instance, you get process tokens or those entitle you to something else. You could exchange it for money. You could exchange it for processor time, something like that. Security. So when you have a distributed system, there is going to need to be lots of awareness of potentially malicious actors. So you're probably going to have gatekeeping and reputation management on these networks. You might have private networks. So kind of what happened with torrents is that you ended up with private peer-to-peer torrents. You might end up with pods of security of trusted things, and they actually talk about that here with privacy as well. So a key limitation of our approach is that peers serving the first layers of the model can use their inputs to recover input tokens. Thus, clients working with sensitive data should only use servers hosted by trusted institutions that are allowed to process this data. So again, security and privacy, it might be answered by the same thing where you have private fleets or federations of distributed GPUs, making changes to the main model. So like if you adopt a new foundation model, but basically what Petals allows you to do is both do inference I think they also allow training, but inference and fine tuning for large language models, which is currently an intractable problem for individuals to do just because it's so expensive. So yeah, this is a really great thing, and you see that it's kind of a global team. You've got some Asian names, some Eastern European names. Yeah, so this is definitely the way of the future. And speaking of distribution, I had folks from Tau reach out to me. And I've had lots of people telling me that I should look into Tau for a while. So what is Tau? Tau is a type of DAO, decentralized autonomous organization. So what is a DAO? A DAO is a decentralized autonomous organization. It is a way of creating and managing any kind of organization of people, whether it is a for-profit company, an academic institution, or even a government. And basically what it uses is the public ledger technology of blockchain in order to register everyone's ownership, votes, controls, that sort of thing. So it is a system of governance. And I know if you, as a watcher, are still skeptical of the power of blockchain for this, keep in mind that Australia recently moved their public stock exchange over to blockchain technology. And there's plenty of other companies and nations all over the world experimenting with both private ledger and public ledger blockchain. So remember that blockchain is not intrinsically public ledger. That's just the Bitcoin implementation was a public ledger. You can have a private blockchain that is not distributed across or that is publicly visible. Anyways, so with a DAO, a distributed autonomous organization, that would be a private ledger, or could be set up as a private ledger. Anyways, I don't want to get too bogged down in talking about what a DAO is, but the foundation team, the leadership team, these are legit folks, all PhDs or otherwise well-established folks with doctorates and professorships and so on. So what is the point of this? Tau is one experiment among many, but one of the things that they're doing is they are working on distributed inference as well. But they have the economy part. So here they talk about incentives. So Tau actually is working on that with their Agorist cryptocurrency. So one of the goals, and this is very aspirational though, is to create something that could replace or augment democracy. So with democracy today, it is very old-fashioned in that you have a straight up and down vote. You basically vote for or against a person or an initiative. There's no discussion. So one thing that a lot of us on my Discord server and Tau and in other places, what a lot of people are talking about is working towards more of a consensus model. And I've talked about consensus before. So consensus is different from democracy in that it is a process of negotiation and discussion and development of new ideas. The scientific community works on consensus, right? You publish a paper, people chew on it, they discuss it, they disagree with it, they write responses, it's peer reviewed. And so over time, the scientific process is very slow, and that is by design, and consensus is also slow, and it's by design, but it is participatory. Everyone gets a say, and then of course someone's reputation dictates or it influences how much their say impacts things. So there's a novel that a friend of mine recommended called Liquid Rain that explores this in part. It basically says a guy goes into a coma today and wakes up in the year, like I think it was 2054, and so it's basically an exploration of how the world might be different in 3 decades. And one of the key features of that novel is that one, it's post-scarcity, and so just by existing, you have an account that is constantly accumulating cryptocurrencies from all over the world, and it's all paid for by basically sin tax, or what was it, indulgence tax, I think is what it was called. Anyways, sorry, I got an itchy spot on my back. But also, so every transaction is a public ledger cryptocurrency transaction in this world, which means that if you buy something that is bad for the environment or bad for your health, you pay additional tax on it, and that tax is immediately distributed to everyone else in the world with no middleman. So that is one possible implementation of a DAO, but then you need a currency built in with that. Also, the political system in this novel Liquid Rain is that it is 100% distributed, in that as long as you are a person on that network, so you're gaining currency, but you also have votes that you can delegate to other people, and you can vote on issues. And that is exactly what the Tau system, I actually wonder if Liquid Rain was inspired by this paper. Anyways, the Tau system allows you to participate in all discussions and contribute to all issues, and then over time, for every individual issue or topic, you build consensus, and then you can also, depending on how you have voted and all of your contributions, you can integrate that with artificial intelligence, and you can have an agent that will automatically vote for you, or eventually automatically propose things for you. And so what you're basically doing is creating a distributed network of generative adversarial networks that are all negotiating with each other on the behalf of people in order to come up with the best decisions that affect everyone, such as things about like lawmaking, environment, public policy, social policy, that sort of thing. Again, super aspirational, but these folks have reached out to me, and I got about halfway through their white paper. There's a few things that seem a little bit vague and hand wavy, but having explored this idea through the lens of that work of fiction that I told you about, and also looking at other things such as the decentralization of artificial intelligence, I think that these folks are really onto something. I don't know if they're going to be the ones to crack it, but certainly we're at a phase where everyone is working towards this direction. So yeah, I definitely recommend you check out Petals and Tau. I'll be talking with the folks from Tau a little bit later, so we'll see what comes of that. And then finally, OpenAI they posted on Twitter, and again, folks from Discord helpfully pointed this out. Sure. Yes. Okay. They are working on creating basically a new version of system of experts, or an expert system. So if you're not familiar, what the idea was in the 80s that AI would be solved by having experts program all the rules and laws of their domain of expertise into a symbolic engine, and that didn't go anywhere. It didn't work because what they found was that there was always something. There were exceptions and nuances that you just could not hard code with formal logic. So OpenAI is revisiting this idea because now we don't have to use formal logic. We can use language models. And so what they want is they want experts in biology, chemistry, computer science, economics, engineering, law, et cetera, and they want to design. They want these people. What it looks like to me is to design fine-tuning data sets of asking the right questions and generating the right answers to those questions. I don't know if this is going to work. I personally don't think that a handcrafted fine-tuning data set is the correct approach. Personally, I think that that doing a more generative adversarial network where you have kind of a peer review process is going to be far superior. But maybe they're doing this just to bootstrap it. Who knows? It's kind of a black box. OpenAI they do produce very good work, but they're very cagey until they produce that work. So who knows? Maybe they're trying to bootstrap a system of experts or an ensemble of experts in order to have a kind of an automated peer review system. Someone actually yesterday alone, I think 2 or 3 different people messaged me directly about having different models or different fine-tuned models, like basically debate or contribute in order to do something better. So there is, and again, this is also a decentralized idea, which that's the theme of the day, right? Is decentralized. And so we'll see if that works. I apologize if I've been all over the place. I hope that you've gotten some value out of this. But yeah, so this is a very exciting time. I miss one day and all this exciting stuff happens. So teach me for taking a day off. Anyways, thanks for watching. Sit tight, stay tuned, and we'll talk again soon.